Can anyone see me? Nope. Because it's there. Oh, hello, everyone. Thank you very much for staying. Thank you also to British Airways for making sure there are, I think, a few more people in the audience than were originally attended. Better? Okay. So I have no excuse. If you can't understand me, it's because I'm unintelligible. I put in for a 15-minute talk, and Jukka gave me a half-hour talk. I think this is a good thing. I don't think I could have done it in 15 minutes. I think I can do it in half an hour. We'll see how it goes. My name is Tom. I am principal consultant at XMLPrague, which is really just a vehicle for me. So it's not the best picture of me, but it's one of the nicest, I think, from last year's XMLPrague. And I'm here to talk to you about the use of a parsing algorithm called Earley, implemented as XSLT. So XSLT Earley. So I'm just... And generally, whenever I kind of suggested this, I get the usual sorts of questions. What the hell am I talking about? Particularly when I try and discuss it with my family. Why would I do this thing? And how am I going to do it? Or how have I done it? Spoilers. So that's the rough outline of the talk. And I'm going to try and talk about some of the ramifications rather than getting bogged down into the details of code, because it's late and some of us want to go home. I'll talk a bit about some of the XSLT at the end. And if people need to know, you want to see more detail, they can come and talk to me. They can go and have a look at the source on Git as well. And of course, you can read the paper. So the first question I expect people to ask me, if they don't already know a great deal about parsing, is what exactly is a parser? Well, actually, this isn't the first question that most people ask me. The first question most people ask me when I start talking to them is about, what is XSLT? I don't think I have that problem here today, so we shall start at step 2 and talk about what is a parser. Well, at a very simple, fundamental, high level, a parser takes a string, and this is the string that I've used here for this proof of concept. It's taken from Stephen's Invisible XML slides, because I'm a great believer in standing on the shoulders of giants. And it's a short program. It assigns A to the value 0. And a parser takes a string and a thing called a grammar that we'll talk about in a second. This is the grammar for that programming language. And it produces a tree. And of course, we're at an XML conference. It's quite reasonable to expect that that tree will be represented at some point as XML. But the more general idea here is that we have a tree that is in some way able to be interpreted by a machine rather than by a human reader. Well, that's great, because that's the principle behind a lot of why I find myself using XML in publishing. So this is an interesting idea to me. I think it's good to have a good understanding of what we mean by a grammar. I think I'm fairly lucky here because in XML we have schema. So we're quite used to the idea of a document that declares and controls the grammar. But I think in the more general case, when we talk about a grammar that can apply to a string of text and to any markup language, we're not talking about schema, obviously. We're talking about things like Backhouse-Nauer format or EBNF. Is there anybody who hasn't ever heard of those things? Either? Everyone's hand goes up. Is there anyone who's never heard of eBNF? You liar. So basically, grammar defines the language's syntax that we're talking about, the language that's embedded in this string that we want to release as some machine understandable tree. And it consists of symbols, labels, if you like. And these symbols can be terminal symbols. So these are things like strings or regular expressions that map to strings, character ranges, that sort of thing. And they can be non-terminals, which are symbols that refer to other symbols. And these things are put together in what we call rules, which is a bullet point I have neglected to create, where you have one symbol composed of other symbols, a sequence of other symbols. And you might have repetition within that sequence, just like you do in a schema language. And you might also have optionality, so optional components within that grammar rule. And of course, those two can combine. So that's kind of defining what I mean by some of the building blocks of this paper, this idea of this parser. I'd like to talk a bit about why that's useful to us. And I think we've probably heard some of this before. Invisible XML is not a very recent idea anymore. It's proposed by Stephen in 2013. I like to think that it's one of these ideas like gravity that has been discovered and formalized. I think it's something that's always been there in potentia. And it states simply that at some level, all data is an abstraction, particularly if we're talking about something that's represented as a string. We've abstracted it to a sequence of characters. So at some level, there's some abstraction, at least one layer of abstraction that's going on. But if all data is an abstraction, then any representation of the same data can be thought of as equivalent. It's merely a case of transforming from one to the other. And if the string that we have can be parsed with a grammar, if it can produce a tree, it's identical to saying that we can treat it like XML. And if we can treat it with XML, we can use the XML technology stack on it. How am I doing? I need to speed up a bit. So, why do we need to do this in XSLT, I guess, is the next logical question. I don't think I have to make a particularly strong argument in this room. I hope I don't. I hope we all love XSLT. You might even love XSLT as much as I do. But there are some reasons why you might not want to use XSLT, and people might ask, well, why use XSLT? Wouldn't it be more efficient to use Java? Aren't there already libraries that do this in XQuery? Yes. And if you're not using XSLT, this is probably not a tool for you. But I think there are lots of good reasons to use XSLT, and why not, you know? Particularly because if we have a solution that's available in pure XSLT, we've eliminated a lot of restrictions about which programs we can write. I have absolutely been in situations where the only processing I've been able to do on some content from, say, a CMS has been using XSLT. There's been no possibility of having licensed versions of the software or additional Java libraries that I can call in. That's an unfortunate truth when you are even a young, grumpy old man. So it's nice to have something in XSLT. And of course, we've got a range of technologies that do this, that use pure XSLT to achieve things in the XML technology stack. And if we have a library available to us in XSLT, we can use those things in things like schematron, XSpec, and so on. Hang on. Some of you may well be thinking, this is all familiar ground, Tom, and there is an XSLT parser available already, right? And yes, there is. Well, there's a parser-generator available. The Rex parser-generator by Gunther Rademacher, which is available on bottlecaps.de. But there are some limitations with Rex. It's a great tool 90% of the time if you want to do what it does, and you don't want to have to wait for me to write the full implementation of Invisible XML, as opposed to this proof of concept, then go there and use this. But it has some limitations, okay? And the most inherent limitation here is it's an LL1 parser. It works by looking ahead. And that means it doesn't actually support all grammars, all context-free grammars. You can normally make it support them by rewriting your grammar, but that involves a level of understanding of grammars that perhaps you don't have. And it will also mean that you end up with an XML representation, a tree representation, that perhaps doesn't match up with what you want as a tree output. Other problems include the fact that the documentation for Rex is pretty much non-existent. It's a hobby tool that's made by somebody who collects beer bottle caps. And there's a very loose promise that one day when he retires, he might document it and release it. But you can produce an XSLT star sheet that you can import and use. And I've done that in the last few months for a client to generate schematron matches from XPath statements, for instance. There's another issue as well, which is, and this really is how I got started down this path. I actually wanted to write a DTD parser. And I thought, great, I can go out, I can get the grammar for the DTD from the DTD spec. The W3C specs all include the grammar rules for the languages they define. Well, I say all the ones that I've been interested in have. So you can actually go and get this grammar. I shall create a parser using this parser-generator, this tool that creates parsers. And I shall parse my DTD, and it will be no problem. But we've already had the problem pointed out to us. Can't deal with entities. I thought, well, it's an XSLT parser. I know XSLT. I'll have a look at it and see how to extend it. And of course, it doesn't really work like that. Because Rex parsers are not supposed to be read by human beings, which I assure you, I am one. There's no scope to use the tools that are baked into XSLT and the XSLT pull processing way of working, the imports and the next matches. All it does is create functions and state tables and sort of directs in between them. And basically what it boils down to is in that kind of parser, you can't change the input as you parse. You can't change the bit you haven't parsed yet as you go through and parse. So, and here's the example we've already talked about. So, the question is that possible? Can it be done? And it turns out yes. I have a proof of concept. It's working. I think it's a relatively small set of steps to turn it into an implementation. But we'll talk about the XSLT itself towards the end if we have time and if you guys want to. And the way to do it, come back to that in a second. And the way to do it is using this trick. Again, I have Stephen Pemberton to thank for it, as well as Michael Spurberg-McQueen. I'll talk about that in a second. Is to use this idea of the Earley algorithm, which is a slightly different way of parsing. It's not always as efficient as an LL1 parser, but a lot of the time it is. And it can cope with any context-free grammar, and it can cope with ambiguous parses. More on that in a minute as well. So I wanted to just quickly point out that there is a slight difference here as well between what I've done and Rex, in that Rex is a parser generator and what I've created is a parser. So parsers like Rex, because they rely on these state tables and these look-ahead functions that are specific to a grammar, can only create a parser for a particular grammar. It just works on that one grammar. And that's why it's a parser generator. The XSLT parser that I've written actually works by transforming the grammar in an XML dialect as an input. And because you can give it any grammar you like in invisible XML as XML format, you don't need a parser generator. You've got a general purpose parser. So that's quite a nice feature. It does mean that the title of my talk is wrong. Sorry. I didn't know when I started. I talk about parser generators. It turns out we don't need one. The parser I've written takes invisible XML as an XML format. And because we're recursing over that using XSLT, the most straightforward way of doing it is to produce an XML grammar. And we've got a great one available to us. Invisible XML has an XML syntax. Plus, it's geared towards producing and customizing the tree, the XML tree that you get at the end. So that's really convenient for our use case. So of course, that's what I chose. But hang on a moment. We've got a great tool for expressing non-XML data as XML. So non-XML grammars can be bootstrapped using this parser so that we can actually support any other grammar language. All we need is a grammar describing that grammar language in invisible XML. So that once it's parsed, the parse tree that you end up with is an invisible XML grammar. Well, that's great. We've got all these other grammar languages, and we don't actually have to write any more code. Winning. The other nice thing about this algorithm is that it deals with ambiguous parsing. So if you have a grammar and if you have a string, there may be more than one way of interpreting that string that's perfectly valid. I think the example that's used quite a lot is about maths. So A plus B times C. If your grammar doesn't have any knowledge of BODMAS or PEMDAS or whichever your favorite term is, then you can interpret it in different ways with the equivalent of different parentheses around the different operations and the order in which you evaluate them. And you might have a grammar for which that's totally valid. It's fine that there are multiple interpretations. LL1 parsers can't cope with those grammars. It's one of the big restrictions. But Earley-based parsers can. And then you can decide what to do with your implementation. At the moment, my implementation returns the first valid interpretation that it finds. But you could quite easily return them all, and you can quite easily control that as a parameter that you pass into your parse function. So you can choose whether you choose a single result or a sequence of results. Either way, the bulk of the work is actually already done with the Earley parser. It's just about how you interpret the thing that the intermediate data format that you create. So if we can return multiple results from an ambiguous grammar, why not parse multiple grammars and interpret them as a choice, as a sort of meta grammar that has a choice between the different grammar choices you have, and the multiple results you return, you can only worry about the first valid one. You've got a very primitive, not terribly well scalable, it has to be said, but you have a very primitive form of language detection. So that's another cool, quick and easy win from this approach to grammars. So if you don't know what your input string is, you can give it a list of grammars to try and return the first one. Okay, so I think those give us some quite exciting possibilities. How much time have we got left? We've got 5 minutes left. There's loads more stuff that I planned to be able to talk about Earley parsing and what we're doing with the tree, the kind of interesting things that Michael Spurberg-McQueen inspired with his parsage talk a couple of years ago, where instead of building a table of Earley items, which is what the Earley processor does, we're actually building a tree, and then all we have to do is prune the tree to find our results. And that's basically how the parser works. I'm regretting the fact that I don't think we really have time to do this now, unless there's general outcry and everybody really wants to see some XSLT. That's a no. I'm not offended. But basically that's the core of the idea. I'm not sure if it's truly Earley, because in building a tree structure, we've got an architectural choice about how we discover some of the parameters we need to do. We also have to change the processing order of how we process the XML, because we have information that needs to be passed from sibling to sibling, and then from last sibling up to the parent sibling, as we process in document order. So there have been a few little hacks around that. And I'm using some functions as we go that basically recurse separately instead of returning the results along with the main parse. So I'm not convinced it's totally as efficient as the Earley parser, or that it's totally equivalent. But I can say that it is at least working. And my hope is that I can turn this into a full XSLT-based invisible XML implementation in the first half of this year. Have we got any questions?
Oh, yeah, over there.
Thank you, Tom. When you say that your parser can recognize the language of the input, are you talking about natural language? Sorry, I know that my intonation there suggested I was going to say something else, but I didn't.
All right, okay. Potentially, yes. You can express natural language using EBNF grammars. And the choice in what it is you're describing in doing so depends on how you write the grammar.
Yeah.
So yes, you can.
What?
You can use it that way.
You can, or You theoretically can.
Yeah, if you can write a grammar for it that my parser supports, then you can.
So we'd be
My
assuming...
parser implementation is not complete.
So we'd be assuming then that your grammar for the... Essentially, we'd be talking about n-grams and so on over the orthographic system of the language, right?
You mumbled a bit at the end.
Sorry.
So there's sorts of grammars, this is beyond the depths of my comprehension, but Noam Chomsky came up with a way of categorizing language grammars. Any context-free grammar can be parsed using the Earley parser.
Right, okay, but the orthography of a natural language is almost always not context-free.
Well, then it can't.
Okay, thank you.
But I'm assuming that you can get subsets which are context-free and that this might work in those subsets, I guess. I don't know. Does anybody have a question not about linguistics?
Well, it has been tried to create context-free grammars for natural language, plus extensions like transformations and so on. But it all failed. Maybe in practice, but it all failed.
Sure. I assume that it's... I said not about linguistics, damn it. Yeah, that's not the main problem that I think we're trying to solve. I think we're looking at data. However, having said that, the goal is to write an extensible parser. And once you have that, once you have this library, then at least you have the option, if something can be expressed as a context-free grammar, that you can use this to solve that part of it, I guess. That's the best I can give you. Arbor.
Oh, my turn. Yeah, you said, shall we talk about code? And then 3 seconds later you said no. That's a bit sad.
I asked, you said nothing.
I was
code?
catching my breath. But if you don't want, I mean, it's the end of the day, so I can totally understand that. But I would definitely be interested in how you did the tokenization part, the parsing part, and everything.
Have a look at the paper. I am writing in XSLT 3, which I'm a bit new and unsteady with. I'm using map parameters to parse which non-terminals have been visited so that we aren't reproducing work or getting infinite recursions. That's quite tricky. I had to write my own merge function because the merge options don't apply to maps within maps. Yeah, the paper deal talks about some of the challenges, and there's also a link onto the GitHub repository for the paper, which has got the proof of concept star sheet. So please do have a look at it. I am very interested in talking to people because I'm sure that there are opportunities I've missed.
I'll have a look.
Thank you. Oh, okay. Still one question or a remark. So, microphone.
Thanks. The glory of Earley is that you don't have to tokenize. You have to tokenize with LL1 because otherwise no language would be LL1. But because Earley is so general, you don't have to tokenize at all.
So thank you all very much. Thank you.